Okay, we see an integrand involving sines and cosines. So let's just, sort of remind you. Um, let me look at right to remind you. But maybe we should just remind you that what we've done over here. And let's see, I think we started with a premise, right? T equals, and that premise, we said T was equal to the tangent, x over 2. From this followed that the cosine of x was equal to, let me see what, I think it was 1 minus t squared over 1 plus t squared. But as I think we derived that, sometimes I can't remember it. Even if I take a 10-minute break, I can't remember. And let me just make sure I said that. Yeah, 1 minus t squared, 1 plus t squared. Sine was 2t over 1 plus t squared. And then the dx was equal to, and again, I'm not going to derive it again, it was 2 over 1 plus t squared. Okay? So here's the deal. You're looking at this integration, and you could certainly do that if you want. Not a problem. What I'm going to suggest to do, though, is maybe don't go to that tricky substitution initially. Try something different. All right, try something. We'll certainly think about it. But right now, I'm seeing sine squared. I could definitely write that in terms of cosines. All right? So let me just go through this with you. And so sine squared, I could definitely, but it may not work, by the way. But I could definitely write that down. And I could factor that. How does it factor? It factors just like this. Then what I could do is I could cancel some of those factors, at least conditionally, and I'd be left off with this. Now, by the way, these are equivalent integration problems. They're equivalent, all right? Now, granted, certainly I'm not looking at, the domains of these things, but right now this is equivalent. Then what I could do is I could use a formula if I wanted to, or I could make a substitution. I will say this, though. If I were using this Weierstrass substitution, let me just erase what I've done so far. I would probably do it here. Someone says, why is that? It's easier for me to proceed this way. But I don't need to do that. But anyway, let's write down. Let's see if things get better. I'm going to take this over here. Star 1 minus, with a cosine, 1 minus t squared, 1 plus t squared. Let's see, 1 plus 1 minus t squared, 1 plus t squared. We'll simplify that later, by the way. Times 2 over 1 plus t squared, dt. It definitely looks much worse, by the way. But I'm going to, step through it. I'll tell you what I'm doing. I'm taking this, and I'm going to get rid of the complex fraction by multiplying top and bottom by 1 plus t squared. What would you get? Let's be careful. 1 plus t squared minus 1 plus t squared. What do you get on bottom? 1 plus t squared plus 1 minus t squared. It's still going to be 2, 1 plus t squared dt. All right, looking at the top, not so bad. What is it going to be? It's going to be 2t squared. This is 1. That's 1. They disappear. 2t squared. What do you get on bottom? Well, look at it. 1 plus 1 is 2. T squareds disappear. What do you get here? You can get 2, 1 plus t squared. What happens here? Well, there are some cancellations, right? I'm going to say 2's cancel. So you get 2 on the outside. Whoops, sorry, I put a star there. Let's see, t squared over 1 plus t squared. All right, what would I do now? Probably a long division. Let's go for that. 1 plus t squared into t squared. I'm going to say 1. And what do you get there? I'm going to say t squared plus 1. You may wonder why I did it that way, because it makes it easier for me to do a long division. What do you get there? Minus 1. Let's write that down. So what do you get? 2. 1 minus 1 over 1 plus t squared. Can I integrate this guy? I can. And what do you get? Let's take a route. You get equals to 2 t minus the arctan of t plus some constant of integration. Let's write this down. 2. What are you going to get there? Tan of x over 2 minus the arctan of t. Well, that's going to just be x over 2 plus c. Let's multiply it out. What do you get? You can get 2 tangent x over 2 minus x plus c. Put a box on it. All right? So let me tell you where I decided to maybe say, you know what, it's time to use that Weierstrass substitution. I did it over here. But if you notice over here, I followed a different path. An easy path too, but it's not a difficult path, by the way. Do I get the same result here? Let's look at it. I get the same result. All right? Again, through the substitutions, look at this one over here. Basically just did what I did over there. We get the same result. All right? It's important, no matter what road you're taking, you're going to get to an antiderivative, and you're hoping those antiderivatives are going to be the same. And if they're not the same, they just differ by a constant. But we did a good job. Thank you.